Okay, welcome to Math in the PM, Math 9. Big shout out to Rami and the guys. See, hanging out. All you guys on the west side coming in. What's that? And the east side. We're talking downtown Brown. You're right, the actual direction. West side sitting on the east side. Okay, back to math. Big shout out to all you North Enders and you South Enders. Me new fenders. He ain't no pretender. He's a contender. Let's get back to the math. Similar triangles. We started this last week. We just finished an activity, but just to review on our similar triangles lesson. We looked at this here and said that there's a bunch of similar triangles in here, 3 of them to be exact. We said, and I'm trying to move that now, but it's stuck. What's that? If it's which? Yes. Yeah. So here's a good question, and I'll just bring it up. Question was, okay, first of all, the big triangle PQR, which I have in green, is similar because of this. Same angle, right? And I can move this anywhere around. PQR is also similar to this little guy. Why? Because these are rough sketches, but the angles are all three the same. You can see that. They're similar, right? Now, the question was, is this similar if it's rotated? So if it's this one, yes, it's still similar because the angles aren't. It's just when you are labeling things and saying which is similar, make sure you get it right. It isn't the torn side and the left side. So you have to keep your wits about you a little better. There we go. Okay. And we just showed this with this activity. What do you know about similar triangle polygons to tell if 2 triangles are similar? All angles are equal, and either one of these, so or, all sides are proportional. They come out to the same scale. Divided. We did the investigation. Done. Okay? So now we're going to flip the page. And here's the summary. You can guarantee both of those things. If I tell you some polygons are similar, the angles are equal, the ratio of the lengths of corresponding sides are equal. But a triangle is a special polygon. When we check whether 2 triangles are similar, the measures of the angles must be equal, or this is where the or comes in. It doesn't work for any of the other sides, number of sides, just 3 sides. The ratios of the length corresponding sides must be equal. If you know that the angles are equal, then you're guaranteed that the sides are. What example can you give to show? I already talked about this one, so we'll give another example. I'm trying to get this back to it. Here's an example, non-example. This is where it's not true. You draw a rectangle, all 490 degrees. A square, very closed off. Out. Okay, 3, and I'm going to pause this too. Okay, our lockdown drill is done, and we are continuing. The non-example we used, all 4 angles of this rectangle are the same as this square, but it's clear that they are not proportional with their sides. So, there's a non-example. Similar properties of triangles, though, properties of similar triangles. To identify that triangle PQR and STU are similar, we only need to know that the 3 angles are equal or that the ratio of the sides are the same digit every time. One or the other. And this is repetitive. You need to have this driven into your head. Why is this set of triangles similar? Why? And this is getting back to Charlotte's question. It's fine that these are twisted compared to each other, not the same orientation, but the three angles are the same, okay? And this is even where the one is a mirror image of the other, not just twisted. Do you see what I'm talking about there? If you were to, I'll show you. What we're seeing here is that this is actually a mirror image. Like, it's not just, if I reverse this, flip. I would first of all have to flip to get it to the same orientation. And then, this. Then they are the same. I'm going to erase all of that. Okay? So they're even considered similar when they're mirror images. When we name two similar triangles, we order the letters to match the corresponding angles. So ABC and QRP are listed like that because A and Q are 75. My board is wonky right now. B and R are 62, and C and P are matched. That's why the order is important. Okay? And then we know how to match sides to sides. Okay? So that's just a review of what we've been exploring. Okay. Let me page 3, guys. Let's take a look. Are these similar? Well, is this one similar? Well, now we know. Yeah, because angles. The angles. So write this down. Similar. Since. All angles are the same. You've got to state your reason. Is it the angles or is it the sides of proportion? Okay. And furthermore, let's get, write the statement down. And then let's get another math statement down. Okay. Can someone name the smaller triangle with the letters? And I'll use that order. Triangle what? Triangle RQP is congruent or similar to triangle. Which side is like the R on the other one? Or which angle? H. So we have to go in this order. H. Since you went Q, then we have to go to M, then M. It has to be done in that order. Now, for B, are these similar? Now, it's definitely not because of the angles. So what you've got to do is test. If I take side 3, how do you make that? My hunch is that's the shortest side. So is it like 6? Well, what's the multiplier that gives you 6? 2. So 2 times 3 is 6. Okay, good. 4 times 2 is 8. This is good. 5 times 2 is 10. This is similar. Since. Now we've got to actually give the mathematical reasoning. 6 over 3 is equal to the side that's 8 over 4. Those are similar sides. And 10 over 5. They're all equal to 2. You see what I did? I'm showing that the ratio, 3 different sets of sides are the same. They're always equal to 2. And then we're going to write down the statement that on the top triangle. I'll use STU. wavy sign over the equals, similar to triangle. Well, S is like between the two shortest sides, 2 and 4. So in between 6, that's J. And T is between the 3 and the 5. So between the 6 and the 10, that's H. Then G. But it isn't necessarily alphabetical order. It's that they have to have the matching letter order, right? Okay. That making some sense? Two ways to tell if there's something. Once we know that, for the blue, for B, we now know that since the sides are all proportional, we know that the angles are equal. We don't know what the angles are, but we know they are the same. Later on, we'll be using this. Furthermore, later on, I told you this similar triangle business leads to something on your calculator in grade 10 that you're going to use. Whether you take workplace math or you take pre-calculus math or foundations math, you can use something called sines, cosines, and tangents. The sine, cos, tangent buttons on your calculator, they only work because triangles are similar. Sides are proportional, and are the same. Now this time, identify the similar triangles. Well, let's just take a look here. Can you guys name the smaller triangle or the large? I don't care which one. Name one of the triangles. RQP. Okay, we're going to take a look at this. Do you guys know intuitively? When I say intuitively, without mathematics, we'll listen to this first. So we know that opposite angles are equal. So this angle R on the left and on the right should be the same, right? So in our other triangle that's the same, angle R. Now we have Q coming up next in the blue. Hey there. Talk to you later. Okay. Q. Which one is like Q on the RST stuff? S or T? On this, if I say this one. Q is like which angle? Oh, Q is like S. No. Oh, actually, I'm going to do that green. R, S, and then T must come last. T must be the same as P. Okay? Now, to justify your answer, we did that aloud. We talked about how the angles. Yeah. There's rules and geometry rules to that. But this, where I say same stuff, this worksheet we're not going to do, but page 349, numbers 4 and 5 are what we're working on tomorrow. I'm going to pause the video recording.